Hello students, welcome to the channel Notion of Mathematics. In this video, we will be learning that how to verify that any matrix is Hermitian matrix or not, or skew Hermitian matrix or not. So for this purpose, I have written here already two definitions. If you will see, this first definition is related to the Hermitian matrix. This one definition, this is definition one, suppose, and the second definition is related to the skew Hermitian matrix. So we will say that any matrix A is Hermitian matrix if this condition is true, and any matrix is skew Hermitian matrix if this condition is true. So for this particular purpose, I have written here two examples. Example A, first we will be discussing about, right? We're discussing about it right now. So I want to verify that this particular matrix is a Hermitian matrix or not. This particular matrix is a Hermitian matrix or not. So before this, I want to let you know that what is the meaning of this A theta. This A theta is actually A transpose and its conjugate. Or you can also say that it's a conjugate transpose. That is also the same thing. Okay. So let me just go with this only, A transpose conjugate, right? So A theta means A transpose conjugate. Now, firstly, in order to get this A theta, what I will be doing? Let me start it here from. So matrix A is given like if I'm saying it is 2 and 3 plus 4 iota, and it is 3 minus 4 iota, it is 2. So firstly, I need here transpose of this matrix. Transpose we already know, right? So it's transpose, this row will become this column 2, 3 plus 4 iota, and this row will become second column. That will be 3 minus 4 iota and 2, and thereafter I need to take conjugate of this particular transpose of the matrix. So that will be transpose of, I mean to say transpose of this matrix A is already there. Conjugate of transpose of this matrix. I mean to say it will be like what? Whenever we get the conjugate of any matrix, what we do? We replace iota by minus iota. So in this particular matrix, I will be replacing iota by minus iota. So it will become 2, and it is 3 plus 4 iota, and it is 3 minus 4 iota, and it is 2. And you know, this is what this is, A theta. This is A theta. Now let me check that A theta is this, A theta is this, and matrix A is this. So are these two matrices equal? Yes, these two matrices are equal. So we can easily say that A theta, since A theta is equal to A, so it means like A is a Hermitian matrix. A is a Hermitian matrix, right? Now thereafter we will go for the validation of matrix B. So for B matrix, I want to claim that it is a skew Hermitian matrix. I want to claim that it is skew Hermitian matrix, right? So in order to prove the skew Hermitian matrix, I have to prove it like B theta is equal to minus B. So firstly, I will focus upon B theta. B theta means what? B theta means B transpose and its conjugate. So let me just firstly get B transpose. So B transpose means what? Transpose of this matrix, that is iota 0 0 0 0 iota, and that is 0 iota 0, and thereafter I will take the conjugate of this transpose. So that will be what? That will be minus iota 0 0 0 0 minus iota, and that is 0 minus iota and 0, and ultimately it is B theta, it is B conjugate, right? And let me now get the value of minus B. Minus B means what? In this particular matrix, let me multiply with minus 1. So it will be minus iota 0 0 0 0 minus iota, and it is 0 minus iota and 0. So let me check that whether this B conjugate, B theta, this particular matrix is equal to this particular matrix. Yes, it is equal to. So we got here B theta is equal to minus B. So what is the claim? Claim is like B is a skew Hermitian. B is a skew Hermitian matrix. So in this video, we learned two aspects of matrices. First is Hermitian matrix, and second is the skew Hermitian matrix. Thank you so much for watching this video.